And then from chapter 5, we'll be doing your exam review, right? Tomorrow you guys have an exam. It'll be here, 9:40. That is if you meet in the classroom. If you're online, the exam will be available from 5 p.m. No, you cannot take this exam as for the classroom online. I have another section in which I do it for the online students. Both exams are built the same way. They are not with the same questions. That is, the way it's going to break out for tomorrow's exam structure, I'll give some multiple choice, some fill in the blanks, and some essays, if you will. And the essays aren't like writing essays like you do in English class. They're just rather lengthy questions. You get one question at a time, you answer it, you move on. There's no going back, okay? So you want to make sure you guys come prepared and you rehearse and study as much as you possibly can. You want to ask questions during the review session. I will be going back over chapter 2 and chapter 3 in the Cisco. I would have went over chapter 4 as well. However, you guys don't have to take chapter 4. And you will have tomorrow until midnight to take chapter 4's assessment. And the only reason why I postponed that is because I wanted to make sure that you guys can go over that PowerPoint video with the TCP, the Transmission Control Protocol. You can access that video under week 4. It talks about the handshakes. The creating a session, 3-way handshake, and the termination 4-way, and how data is reliably transmitted using TCP. Watch over those PowerPoints. If you haven't already watched it, you want to definitely do that. If you did, make sure you're asking questions during the review. Chapter 4 stuff is testable. I will not be posting a Chapter 5 assessment this weekend. I'll be going over some Chapter 5 stuff today, and we'll continue that on Monday. Unfortunately, the best way to understand Chapter 5 is by going into Chapter 6. So today you'll see me jump into Chapter 6. It should look foreign to you unless you're really reading ahead. And make sure by next week you guys have Chapter 5 down. You read, you watched the videos, you looked at the overview, so that Monday we're getting into the real questions of Chapter 5. And the real question is, how do we deliver packets from network to network? First of all, why are we taking this network? And I had yesterday in class. And why are we dividing them up? Oh, let me make these a host of windows. Now I'm not going to go and draw 24 of these out. I'll draw a couple, and then maybe I'll write underneath that 24 hosts. Why would I want to take that network? That's only requiring one device, a switch, and divide it up into several networks and make this even more complicated for myself. It doesn't seem like it's, why go through creating all this extra work? Like a jigsaw puzzle. Why would somebody want to take a picture and break it into tinier pieces and put it back together? Why would I take a network, break it into tiny pieces, just for them to be able to communicate with each other when it seems like life is good here? What's the biggest drawback by taking 24 devices? And you know what? 24 is probably not that bad. We have about 20 in this network. Not too noticeable. What if I made 240 devices? Why in the world would I do that? Why would I want to break those up when it seems like it's just pleasant to have it as one network? Any ideas?
So information travels faster and more efficiently?
Okay, now that's where things start to depend on how we dictate speed. I mean, if I have to go from device to device to device to finally get to my destination, then I'm adding all this extra overhead, so maybe speed might not be a concern, but there is a performance issue. In fact, that is one of the #1 reasons that we do this, is we're looking at performance degradation. The more and more devices we add to our networks, whether we're using switches or hubs to interconnect those devices to our network, the greater chances we will have of collisions. Now, a switch is designed to help minimize collisions and actually eliminate them. But there are times where we will get collisions. We're dealing with a lot of broadcasting. In fact, in yesterday's class, I demonstrated this technique called ARPing. That's used when? When do we use it? I mean, the command that we do to display our ARP table is ARP-A, and what we would get is like a logical address, and we get a physical address, And what ARP will do is actually translates our logical address like 192.168.1.20 into a physical address like A1:1:C2:AF, 1F. Let's see, do I have this correct? Let's see, 8, 16, 24, 32, I need to add 2 more. And we'll just say 2C1D. A physical address is 48 bits, but just to give you an idea, it's usually in hexadecimal format. When is this service required? When am I initiating that?
When you're looking for a host on a network.
I'm looking for a host on my local area network, right? Because for local delivery to actually be conducted, I have to use physical addresses, not logical addresses. In fact, logical addresses are only used to get us from network to network. From there, we switch over to physical addresses. More on that later, and how we define local and remote networks. But regardless, when we look at this network, when this host wants to communicate with that host, before it can do that, it has to check its ARP table. And why do you check its ARP table? Because this is the process that's going on. Let's just say hypothetically, this is a web server, and this is my web client. So here I am at layer 7, creating web data. Web data gets passed down to, let's just skip over 5 and 6. We're at layer 4. We're going to take that, we're going to create a segment, correct? Idea that I'm going to be looking at is I'm going to say source port. I'm the client making the initial conversation, so what number am I going to pick here? Anything before 49,152 up to 65,555, right? I'll just say 60,000. And that's that dynamic range. Alright, what about destination? I'm a web client looking for a web browser. What's my destination port address going to be? 80. I take this segment. Remember, I had the data from the web, passed down into the segment. I'm encapsulating it. And now I'm going to pass this down into what? Layer 3, which is the network layer, which is what chapter 5 is all about. And I'm going to create a packet. And that packet's going to ask for a couple of pieces of information. Actually, it asks for a lot more, but once again, we're back to source and destination. But what source destination addresses are we talking about? Source IP address if we're using IPv4. And that becomes a question because when I look at my diagram, what are my devices' IP addresses? Well, let's say we say that this network is the 192.168.1.0 network. Now this host address is .1, this host address is .2, this host address is .20. Oh wait a minute, I had to make this one 20. Let's make this 10, 30, 40. Now you see the shorthand I just did? I didn't want to write out 192.168.1.10. Because by me labeling this network as having an address of 192.168.1.0 is no different than you being labeled to have a last name, correct? My brothers and I have the same last name. So when I call up my brothers, I don't say, hey, Joe Andre, how you doing? I just simply refer to him by his first name, correct? So here, I'm trying to find out what part of my address represents my first name and what part represents my last name. If I'm using IPv4, now I know it looks like I'm going off on a tangent. And it's very true, I'm going into chapter 6. Why am I going off on this tangent? Because I don't know what to put in here. I'm filling out a form and there's something they're asking and I'm like, what the hell is that? What are they asking for? What is a source IP address? What do I put in there? And why is it considered a logical address and not a physical? So when I look at an IP address, I notice there are 4 parts to it. Whoops. Each part's called an octet. And the reason why we call them an octet is because each part represents 8 bits. If you're doing your math correctly, if there are 4 parts and each part represents 8 bits, how many bits represent an IPv4 address.
32.
And so if you had to take a guess, how large would this field be in the packet header?
Huge.
32 bits for the source and 32 bits for the host. And if you were to take 2 raised to 32, that's how many different unique hosts you can represent in one single network. Which is why we like to take our networks and divide them up, because we can reclaim and reutilize some numbers. Chapter 6 stuff. So when I look at this, I got to determine, okay, let's switch over to a phone number scheme. And if I look at a phone number, I see that a phone number has parts. And you see that this particular part is sectioned off in parentheses, and then these two parts are separated by a dash, correct? Some people get rid of the parentheses, and they put dashes. Regardless, if I would have left that like this, without any dashes, without any spaces, you know that a phone number, our phone numbers, have how many digits in them? 10, right? We gotta count the area code.
Okay.
You good about that? So if you see a 10-digit number, you know the first what are? The first 3 represent the area code. Good about that? And you know the next what?
Region?
3 represents what we call the local exchange. And then the last what? 4 represents the line number. We call that a hierarchical address. We good about that, folks? Let's look at IP addresses. First of all, how did you know the first 3 were the area code, the next 3 were the local exchange, and the last 4 was the line number? You've been conditioned all these years that when you dial a number, this is the way you're supposed to dial it, correct? And sometimes you have to dial 1 before it, correct? Now I know you guys don't dial area codes around here. Where I'm from, we have to dial area codes. In fact, it's such a bad habit that when I pick up my office and I want to call somebody in Elmira, I'm constantly dialing 607. And then my operator says, sorry, but this number doesn't require an area code. And I want to tell her, look, just remove those 3 digits that I accidentally dialed instead of me redialing those 7 digits over again. Talk about punishing bad behavior, right? She's smart enough to tell me that this number doesn't require an area code. Why is she smart enough just to remove that area code and just process the 7 digits? Customer service. So you guys have been trained and conditioned to accept this structure. A protocol, right? Call this a telephone protocol. Well, I'm going to teach you IPv4's protocol. Actually, I'm going to teach you IP's protocol. Back in the original day. In the original day, we used something called class. I know we don't use that much today, but it still pops its rear head up. We had a concept called classful addresses. And the 3 major classes that we learned about, or we will learn about too, will be class A, B, and C. And like port addresses, remember how port addresses got divided into 3 categories? Well-known, registered, dynamic. Like port addresses, we divided up our IP addresses into 3. There's technically 5, but 2 of them are not allowed to touch. So let's just say these 3. It'd go from 0 to 127. Now 127 is reserved for loopback stuff or troubleshooting. I'm going to throw it in there as part of class A.
121 to 191.
128, right?
Or, yeah, 128.
To 191. And I'll show you guys how to calculate this later. And then class C would be what?
192 to 224.
223.
Yeah.
Because the next one would be 224. Very good. Now, whip-de-doo. Now that I know if a number begins with this, and I'm looking at this particular octet. So you know a classical address, you look at the first octet. No different than when you guys look at the first 3 digits. You know it's going to be a long distance call or not, correct? So when I look at this octet, I try to find a match in these 3 categories. I found a 1, so that would be a class A. And that's going to tell me how many octets represent the network address? In other words, it's going to tell me where the last name can be found. You good about that? For a class A, it just means that the first octet is going to be the network address, and that means octet 2, 3, and 4 are what?
All hosts.
The host name, your first name, if you will. Everything's kosher? Let's move on to class B. If you find a match in the first octet between 128, including 128, up to 191, including 191, that means the first and the second represent the network, and then the third and the fourth represent what?
Host.
So what do you think what do you think class C is going to be?
Network host.
First, second, and third are going to represent the network, and then the fourth represents the what? The first name, the host address. Do you see why I excluded the 192.168.1? And my shorthand I just put .10, a .20, a .30, a .40. Because for these devices to communicate, they need to be on the same physical network as well as the same logical network. You good about that? Now we're going to explore how devices on different networks are able to talk to each other. But for now, they're on the same logical network because they have the same network address. They're on the same physical network because they are connected by the same device. Clear about that? The fact that they're on the same physical network is what's causing our problems. Because no two devices on the same network can have the same what? Address. So once I assign these computers these addresses, I can't reuse them. And so what I want to do is I want to create some kind of structure where if I change a single digit, I can reuse the rest of my numbers. Does that make sense? So I have this area code stuff, and I have these local exchanges so that I can subdivide everything and create this hierarchical approach, which leads us into this concept called logical and physical addresses. At this particular point, layer 3 is all about the logical addresses. It uses logical addresses for end-to-end delivery. I said I was this component right here, this client, wanting to talk to this host. So for my source address, I'm going to put in 192.168.1.40. I have to fill in all 32 bits. Is it 30? So, yeah, 40. 40. What do you think I'm going to put in for my destination?
About 20.
Well, I got to put in the rest, all of it, right? 192.168.1.20. So I'm adding this onto my segment, creating another header. By doing that, I create a packet. And then I'm going to pass this packet down to layer 2. And what does layer 2 produce? A frame. And that frame contains of a header and a trailer. If I look at the header, I'm going to see once again source and destination. In fact, we had source destination here, we had source destination there, and we have source and destination. Let's rewind. What were these source and destinations used for? To identify what? Applications or services that are running on end devices. You good about that? What are these source ports, these source addresses and destination addresses used for? To identify end devices. Okay? What is a physical address used for? What would I put for my source physical address? I don't have them displayed. I'm going to have to do a command like IP config. Maybe right click on my network adapter and display the properties. And let's just say for argument's sake, this one's A2, this one's A3. I'm just doing a shorthand because I don't feel like writing out all these fields, all these characters. And we said this one's A1. and we say, we'll just make this one A4. These addresses are physically burned into an interface card. But what I put in for my source physical address, my MAC address, and they're used for accessing the media, hence the name MAC, Media Access Control. It's me who's making this request. So I'm going to put in A2, because that's my physical address. And where is this destined to go to?
A1.
How do I know that? Because I look at the destination IP address, 192.168.1.20. And then I go into my ARP table, and I find a match. Now 1.20 is A1:11, so on. You good about that? That was a demonstration I gave you guys yesterday. So I put A1 here. And then I add my trailer and I fill out the rest of the fields. And then I ship the frame across the wire, using signals to represent the zeros and ones. That frame comes up to the switch. Where's it going to go from the switch?
For the host.
And that becomes an interesting question. The switch has to ask itself, do I have this MAC address, A1, in my MAC table? Because the switch has to take that, and that's why we call it physical address. A physical address, and match it to one of its ports that a device is plugged into. If it cannot find a match, what do you think the switch is going to do?
Throws the packet away.
Not yet. It's going to be a frame, and it might send an ARP request. Hey everybody, I'm looking for this. Hey, remember we were doing the difference between a hub and a switch last week? And remember when it was first building up its MAC table, both a hub and a switch act the same way and it broadcast it to everybody? Remember that? Why did the switch do that? Because that means everybody gets the chance to look at that frame, but only one's going to fess up to it. That's me. Here's my MAC address. And if nobody fesses up to it, then the switch will discard that frame. I don't have anybody plugged into it. This is local delivery. You see the important thing though? The more hosts I have on this network, what happens to the number of segments I have to send out? And the longer it takes to converge. Hence, what happens to my performance? It degrades. You guys get the idea now? Why we're going to break this up? It takes more work and more energy to break a network up into smaller subnets. But once it's done, you shouldn't have to redo it, especially if it's done correctly, and the performance gain should be exponential. Because it's not just every time you communicate, but it's every time everybody else communicates. Next, the second reason, or technique, to breaking these networks up is what? What is the maximum distance using Ethernet as our local means of delivery? 328 feet or 100 meters is the maximum distance I can go from one end device to either another intermediary device or another end device. Right? Because remember what intermediary devices do. They retransmit the signal, hence acting as a relay or an amplifier. You good about that? Alright. What if I want to connect to somebody that's miles and miles away? Does that become possible? And how or what types of medium would I use to make those distances? You think I'll be using Ethernet Cat 6 or Cat 5 cable to do that?
No.
No. Can you guys give me a couple examples of where I'm going from miles and miles away? What about fiber? Could I use fiber?
Yeah.
What about satellites?
Yeah.
All of which I cannot afford. So what do I have to do to be able to have access to those resources? I pay a monthly bill, right? And I get an internet service provider. And what am I developing? We call it a wide area network. When I take all these little networks and I join them together. You good about that? The next thing I get by taking my networks and segmenting them, or subnetting them, is I also get an extra layer of security. Because now I'm introducing a door to my network. Before it was all open. Anybody could walk in. And when I introduce a door, a gateway to my network, a router, I can filter out things. I can say, hey, you're not allowed here because your IP address isn't acceptable. It's not on the white list, the approved list. In fact, when you guys do some of your online gaming, you might have a little thing that pops up saying you're behind a NAT and it's affecting performance and so on. Part of the router's causing this responsibility, part of the router's responsibility is just this. Question?
Oh no, I was gonna say it's also really good for companies too because they can pinpoint where an intruder might be on the inside by their subnet and IP address.
And that's why the other thing we look at when we divide our network is by geographical location. We can do it by floor, we can do it by building, we can do it by city. Whether it's the intranet or the internet, these routers connect networks together. Now typically, in a building on a floor, we'll usually have the switch act like a router, and we create what we call VLANs. But the idea is, what is a LAN? It's an individual network. And what is a network?
A grouping of end devices with a
Two or more devices connected together. Remember, this goes back from the way beginning. That's very very testable question. Two or more devices connected together to share resources governed by a set of rules over a common medium, right? If you're sharing resources, shouldn't you want to try to put all the people together that share like resources together? That's another purpose of the subnet. So I'm going to take this concept of this much larger network. I want to divide it into 4 places, 4 pieces. And in order to do so, I'm going to have to change my network address slightly to accommodate this local concept. And that's what I was trying to lead down to. Logical versus physical. You can think of this as being like a phone number versus your house number. Which one's easier to change?
phone number.
Phone number, right? To change your house number, how are you going to do that? You can't. You got to pick up your home and move it down the block. Because house numbers are allocated by physical distances. In fact, I live out in the country and we have a number. We're the first house on the road. You want to guess what our house number is? 66. Just scratching their head. And they're like, okay, we're the first house on this road. But they're saying that, well, here's the road and your house is like a mile up the road. And they're thinking we could divide that if you were to ever subdivide and sell your property. We could divide that up into 66 pieces, right? So each piece would have an address. That's why I'm saying your house address is actually dictated by physical location. If you want to change your address, you got to pack your stuff up and go. Physical addresses are burned into devices. And as I was telling my class this morning, and some student actually had the same story that I had. This past summer, we went down, 2 summers ago, we went down to Myrtle Beach, and you know, most of you guys are familiar with these like keyless entries. And I went to go lock my car, and I heard another car beep. I looked around, and I said, no, wait a minute. Pushed it again, and that car beeped again. It was a Honda, 2005, but it was blue, mine was black. I'm like, wait a minute. So then I unlocked it. Her door's unlocked. I'm like, what are the chances of that? These wireless key fobs actually have a signal, which we would call a MAC address, right? And the car has to listen to that MAC address. It's just a sequence of frequencies. And it detected that and said, hey, that's me. Unlock my doors. And that happens because they only have so many different frequencies they're allowed to use according to the FCC. So what does this manufacturer have to do? Reuse them. But how do they distribute them? By region. What are the chances of somebody who lives in Pennsylvania that's going to go down to South Carolina that has a 2,500 cord and park next to somebody that has the same 2,500 cord and that their wireless frequencies are going to match?
Obviously, in your case, pretty good.
It was. And the student was telling me that his key, which is a physical address, if you will, to unlock his girlfriend's car and start it up. And think about how a key is made. It's just pits and valleys.
So that's how the car thieves do it, huh?
Yeah, I just got to copy them.
Yeah.
I shared a story with my students before, but we'll get into that another time when we get to this chapter. But regardless, it's a physical address, and I cannot change this as easily as I can do what? Change my name, change my car. I mean, to me, to change my actual locking mechanism and my frequency would be a nightmare. I had to go through them to pop out my ignition and then pop out the engine immobilization code. It's just getting harder and harder. It's becoming more of a difficulty. So we couldn't say this physical address. Whereas a logical address, like a number on a door, can be easily changed. In fact, if you want to screw around with your friends, we do this in college all the time. We would just go to the door, take off the plates, and then move them down. A lot easier to do than changing the locks, right? And so the freshmen, every time they'd come in there, they'd say, because they're new to the whole system, they have to look at their room assignment and then try to take their key and it doesn't work. And so the resident assistant would be having a hell of a job because now they'd all be knocking on there like, my key doesn't work, but it works on his door, and this is all messed up, and it's all because we shift the plates down. Logical addressing. We can take our networks and we can divvy them up a way we feel is necessary to accomplish our purpose. All that stuff is logical. It's a thought process. It's a purpose. It's a resource. Physical addresses, we can't do that. Or not as easily as we can do it with logical addresses. Now when I say can't, yes, there's people who have done it. And people continue to do it. It's just a level of difficulty. Logical is just a matter of you guys going to your control panel, right-clicking on your network interface card, and going to properties. Physical, more entailed. You might have to buy a new network interface card. But the idea is that they're burnable, they're physical, they're mapped. No different than your house number. It's a logical address. How do we map your house number to a logical address? Your phone number. Look at a phone book. Not only is your name mapped to a number, but isn't your street address also on that? Mapping a physical address to a logical address. Let's see this in action. Let's take the network and let's divide it up. Alright? One part of that. Let's say it's quadrant 00, so that's where the web server is stored. I'm going to have many devices on this network. I call them nodes, but for today's class, let's just call it a host, so we don't get the N mixed up with networks. And we'll get into that device later. This is its own local area network. Its own LAN. What is this network going to need? What did that network have? To create that shortcut. It's going to need an address, right? Let's call this one 192.168.1.0. Right, this is our first quadrant. We're going to put that in that network. You good about that? If I want to create another LAN, that also needs a network address. So this is LAN 1, hence the 192.168.1. And how do I know this is the network address? Where does that 192 fall into? What class?
Class C.
Class C. What does Class C tell me? First 3 octets represent the?
Network.
Fourth octet represents the?
Host.
So this one can be 1. What do you guys want to make this host?
2,
You guys want to make this host?
3,
You guys want to make this host?
4.
No two devices on the same network and on the same address. Is that correct?
Yep.
Do they have the same address?
No.
192.168.1.1.2.3 or something, 3.4. What about this one? This is
192.
LAN 2.
That 2.0.
Let's make it this quadrant in the upper left corner. Are we good about that in our diagram? So 192, still sticking to the Class C. 168. Brian, what do you think?
Dot 2.
Dot what?
Dot 1.
We're going to do the network address. We'll talk about how to define that. Okay. Do they both have the same address? Let's see. Let's make this one dot 1, dot 2, and this one dot 3. Am I going to have a conflict between these two hosts?
No, because it's dot 2.0 and dot 1.0.
Do you see how the last name now comes in? You see how the network address helps to separate those two? Will this cause a problem? No. The logical addresses are different. Even if I were to connect these two networks together by a switch, I will not have a problem because that network address being separate. We're not gonna use a switch to get these two going.
Use a router.
We will in a second. But let's look at this. What if I altered this and said, let's leave this as a .1, and let's make this a .3? Is that still kosher? Why is that okay? Why did I decide my first time to change the 1 to a 2 and leave that 192 alone? But this time I'm changing the 192 to a 193.
Still a Class C.
According to the classful address, all I have to do is change any one of the octets, first, second, or third, to get a new network address. Good about that? Typically we start on the right side. We work our way to the left. But there's no rule that says you can't change it this way. In fact, there's no rule that says I even have to make this 190. Well, I should make it 192 because it's Class C. But then the next one 193, and then the next one 194, and create new addresses, new network addresses. Alright? All I have to do is change any one of these octets to get a new network address. Then I assign the host each of their own address. Would this be okay if I change that .3 to a .2?
No.
Because I have two devices on the same network with the same address. And just to keep things simple, I'm going to make this back to a .2. Right there. Good about that? And if I wanted, I could do the other fours. It's the same thing. Take those take that large network, divide it up into pieces. Now, let's talk about local delivery and remote delivery. If this particular host wants to communicate with this particular host, how's that going to happen?
You're going to need a router with a default gateway to get out of the network.
Yes. Earlier when we were doing this demonstration on devices communicating on the same network, what I had to do is I actually had to have physical addresses, and they all had to be connected to one switch. And I had to make sure that they're all using the same, what? Network address? They're all part of the same 192.168.1.0 network. And then I went down through the process, and I said this device, before it actually sent a message to that device, looked at its ARP cable, correct? When it looked at its ARP cable, it had a physical address, and then it determined to put that in here. So the question really comes into, how are these two pieces of PDUs filled out? We good about that? So that leads to this process of remote delivery using local devices. And so when I start looking at my networks, I'm at this point right here where host .2 on the first LAN wants to send a message to host .3 on the other LAN. And it's going to go through the encapsulation process. You good about that? And it's going to finally get to the packet. And it's going to have to fill out a source. It's also going to have to fill out a destination. What am I going to put for a source IP address?
192.168.2.3.
192.168.1.2 because that's me, right? This is my last name, 192.168.1. This is my first name. So .2, I got to fill that all in here. What do I put in for destination? 192.168.2.3. Alright, now, let's assume something. Let's assume that our networks have converged. What I mean by they converged is that every device on our network has a completed ARP cable. So the ARP process was done. We did that yesterday in packet tracing. And that my switch on both networks have their MAC cables filled out. So they basically, they know who's plugged into it. And we also have a router, correct? A way out on both networks. And now these routers are connected together. You good about that? If these are considered local area networks, then this network between here and there is considered a wide area network. Okay? Also called a public network. I need to give this device an address. What address should I give that?
192.168.3.1.
That one's used.
Or, well, no, because if it's
I want it on
where you-
this side. I'm talking about this side,
Oh, alright.
not the public side.
.5.
That's the next available number, right? But I'm actually gonna do .254.
Oh, the last usable.
Why am I using the last usable?
Because the
So you
first
can get
usable is
roles
not
on it.
available.
So that I can add other hosts in here without having to change around things, because it would look asinine to have .5 used for the router than another host is
But you didn't
.6.
have to, right?
I didn't have to do that. I just want to make it easier for me to troubleshoot. Because when I get into it, and I'm in the thick of troubleshooting, and I'm like, what the hell is a gateway again? Well, I know my policy is the last usable. I know what network I am. I know what the number of hosts this network can handle. So it's going to be .254. Allows me to follow the same procedure from host to host without getting lost in the network. Okay? So can I do the same thing over here with this one?
Sure.
Yeah, there's no rule that says it can't be done as long as the network address is different. You good about that? Alright. This gets down to a frame. What am I going to put for the source? Let's just say this is A2. And let's make this one over here B3. And let's make this one here OB254. Well, can't technically do that. Let's make it BF. Best friends. And let's make this one AF. Alright? Technically, you guys saw the structure of physical address. It's a lot larger, but it allows me to shorthand this. What am I going to put in for the source? MAC address. Remember, I'm here. I'm the one sending it.
B3.
A2, right? What am I going to put for the destination?
B3.
AF. Wow. Ryan, why do you say AF and not B3?
It's gotta go through the route first.
Got to go through the router to get to the other network. Okay? Physical addresses are used by the switch to identify what ports. If I were to use B3, will that address be in this table?
No.
No. But you know, I'm here creating this frame. Do I know what's on my switch table?
No.
I have no clue. What do I know? I know that my network address is 192.168.1.0. So the source destination address is, what's my destination, sorry, the source network address is 192.168.1.0. Well, what's my destination network address going to be? What is the destination network address? 2.0. Are they on the same logical network? Do these two numbers match?
No.
No. So the first step, when you're transmitting, determine whether or not the end device is on the same logical network as you. Alright? If it is, don't bother the gateway. Come to the switch and transmit, right? So in that translation, if it is on the same logical network, do an ARP request, find out what the physical address is of that device, and put it in right here. And then ship it away. If they're not on the same network, check your routing table. Every end device will have a routing table. In that entry, there's going to be a default route, which is why you guys call this device the default gateway. Translation, it's the catch-all route. Any and all networks, except for my network, should be passed to this device. Does that make sense? Any and all except for my network. .2.0 is another network. So I'm going to pass it to this device. In order for me to pass it to that device, I have to put in AF for my frame. Good about that? That means the switch will get it, look at where AF is hooked up to. It's out this port. So then it'll pass the message to the router. This router will say, hey, that's me. I'm going to de-encapsulate the frame. And then what's going to be exposed for the router? The packet, right? And you know what that router is going to do? It's going to look at the destination IP address, calculate its network address, and it too is going to look at its routing cable and say, do I know of a path, which we call a route, that can take me to this network? Let's say for argument's sake it does, and it passes it to that device. Does it do that? Well, these have some some frame addresses as well. So it might change, it'll reframe this, and now the frame's going to read the following. C1 for the source. And the destination of being what? Because it has to go from here to there. By the way, that's called a hop. Think about that. What do you think this router is going to do? De-encapsulates the frame, looks at this, and it asks itself, what is the network address for 192.168.2.3? Comes up with 192.168.2.0, and it says, oh yeah, I know about that network. That's here, right? And it too will do an ARP request, and it'll find out when it goes to create a new frame that the source now becomes, we said this is PDF, right, best friends? That's going to be the source. And what's the destination going to be?
Three.
And that means it'll go to the switch. The switch will look at the frame, realize it has to come out of that port into this. This one will look at it. It'll de-encapsulate the frame, say, yep, that's my MAC address. It'll look at this as, yep, that's my IP address. Then what other encapsulation will look at? Looks at the segment, right? The transport layer. It says, yes, I have a web service running because port 80, correct? And then it'll take that segment, put it back into data, and pass it up to the web server. You see this process of using addresses. We're going to explore more of this next Monday. I need you guys to read chapter 5 because it's really thorough. This relationship here to here. In order to get to that, we had to understand some chapter 6 stuff. Chapter 6 is all about IP addresses. Okay, folks? Alright, let's do the review. So the way we're going to do this review is I'm going to log on to Cisco. I unlocked Cisco chapter 2 and Cisco chapter 3 exams. Okay? I did not unlock Cisco's 4 because you guys still have until tomorrow night to take Cisco 4. Sorry, Cisco chapter 4. You good about that? Alright, I gotta wake up my computer. And what I'll do is I'll walk through the questions, go all over them, tell you guys some techniques on how to take a Cisco assessment. Oh yeah, we moved it off the network because it has this roaming profile stuff that's causing problems. Alright. So I opened up chapter 2. By the way, you guys can check how well you scored, and you can get this feature plus where you answered or what you answered by going to the grade book on the left side. If you're not sure on how to do that, let me give you a brief demonstration. I don't want to show anybody's grades. If you come over here on the left side, you guys will see grade book after you log into the fall 12 course. Oops, I need to sign in again. Alright, so I logged into Cisco's website. I'm going to click on the fall 12, CSNT 12. And then when I do that, I'm going to get this new menu area over here on this left. I'm going to click on the grade book link. And like I said, I'm not going to reveal my other students' answers, but I will show you that I have it unlocked for you. So if you want to know how well you did, you can click on that chapter and then it'll bring up every question across for that particular chapter exam. then you can click on those and you can actually read the question and then the answer and the correct answer. But for this class, for reviewing, I'm just going to unlock the assessment and look at it from a whole perspective. And if you're getting up your chapters, now's the time to ask the question. This is the best. User doesn't exist. Alright. Give me a second, folks. I apologize. Let me get out Firefox. And this is why I don't like using Internet Explorer. We're going to be doing chapter 2 as a review. And then we'll go into chapter 3. Sorry for this. Let me go to fall 2012. All right. So chapter 2, you guys took this a couple weeks ago. The very first question we get is which statement correctly identifies the role of intermediary devices in the network? Choose 3. Sometimes the best way to answer a question is eliminate what you already know. I'm allowed to pick 3 out of 6 total possibilities. Remember, if you pick any more, they will mark the question wrong. And so they're asking about intermediary devices. Devices can fall in 2 categories, right? They're either intermediary or what? End device. On your study guide, I noticed a lot of people got that one question wrong when it comes to communication servers. You're thinking because it says server that it's an end device. It's actually an intermediary device. A communication server relays the message after it records it. Okay? So we look at this circumstance. We look at the role of an intermediary device. Well, let's eliminate what I do know. I know that intermediary devices are not allowed to generate data, correct? Who initiates the conversation? Clients or end devices, correct? So I see the the second option says initiates data communications. Well, that's an end device, not an intermediary device. So I'm going to rule that one out. I'm going to skip over retime and retransmit. And I'm going to come down to originate. Isn't that the same thing as saying, initiate and originate? So those two are the same. If I rule this one out, I'm going to rule that one out. Then I'm going to come down to the last one. It says final termination point. The name suggests that, an end device, correct? End device. It's going to stop here or begin here. Intermediary suggests it's going to be in the middle. It's going to pass it through. So if I rule out those 3 choices, I'm left with 3 choices to be picking from. Let's look at those. Determine pathways for data. Which device does that? What did we learn today? It does that. It looks at its routing table. This device is called a router. Another word for pathways is called a route. Let's look at the third one. Retime and retransmit. I actually said that again. I said the maximum distance for an Ethernet network is 328 feet. I said that's between an end device and end device, or between an end device and intermediary device. Once it hits another intermediary device, it will retransmit it and also re-signal it. Hence I can go back and retime. What about the third? This one would be what? Option 5? Manage data flows. What's another way of managing data flow? QoS, right? Quality of service, talked about that chapter 2, chapter 1. Alright, let's look at the next question. Choose 3, select the statements that are correct concerning network protocols. This is the OSI model. What are protocols? Set of rules that govern how we communicate, correct? So when I'm looking at this, what about the first one? Define the structure of layer-specific PDUs. What was I doing right here? Was I not filling out the PDU structure? And how did I know that TCP was asking for a source and destination port? Because the protocol told me to do so, right? So I'm definitely going to pick this one. Define the structure of the layer PDU. Let's look at the next one. Dictate how to accomplish layer functions. Did TCP tell the software how it's going to do it? When you guys fill out a job application, does the job application tell you exactly how you're going to fill it out? They ask you to fill out particular fields, but they don't tell you what hand you use to filling it out. They don't tell you what table to be writing it on, what pen to use. Some of them do get a little specific, telling you, pencil or pen. They don't tell you whether to capitalize every letter or what language to use. They tell you what they prefer. But the idea is, they're not telling you how to do your job as much as they're telling you what needs to be filled out. And why does that field need to be filled out? Because it leads to this option right here. It outlines the function necessary for communicating between layers. These fields are going to be used for other layers on other end devices. Make sure you fill them out correctly. I'm not going to tell you how to do it, but I'm going to tell you they're required. So far I've picked what? The first one and the third one. Did I ever tell you in this course that in order for you to use this printer, or to use this network interface card, or to access the internet, you need to have Microsoft Windows? It never came up. I said this is platform independent, right? So that eliminates that option. What about this one? Requires layer-dependent encapsulation. What's another thing that encapsulation does? It produces PDUs, right? If we're talking about the structure of PDUs, then we should also be talking about dependency of PDUs, right? The encapsulation. So I'd pick out 1, 3, and 5. What about this one? What are two functions of encapsulation? Sort of leading up to the previous question. Does encapsulation track delays between end devices? But I mentioned any fields that deals anything with time delays. Now, not encapsulation, maybe a particular field does. What about enables consistent network paths for communications? Do we talk about how a particular path will always be followed according to this particular data? Let's go on. Allows modification of the original data before transmission. I made a big stink about this first week of class. We can take the data, we can break it up into segments, and we can add headers to it. But what are we not allowed to do? Alter the data. Why not? Because by the time it gets to the service or to the application or service might not understand it. Does that make sense? Viruses do this, and they cause corruptions. What about this one? Identify pieces of data as part of the same communication. That's an exam question. I don't ask it that way. I will ask what protocol is used and what field in this protocol is used to identify pieces of the same communication process. First of all, what layer takes the data and breaks it up into pieces? Transport layer. And we call these pieces what? Segments. Alright? So, we're at this layer, which is definitely part of the encapsulation process. And what does that layer do to identify those pieces? What does it use? What field? Give you a hint. Got the word number in it. Sequence number, right? You have to watch that PowerPoint. It's online about the handshake. It talks about the data flow. Next answer, obviously would have to be the last one if I eliminate everything else. Ensures that data pieces can be directed to the correct receiving end device. What layer does that? We learned about that today. What layer handles end-to-end delivery? What layer is chapter 5? Network layer. In fact, you guys are saying, well, if that's chapter 5 stuff and we learned this today, why was it on chapter 2's question? Why was it on chapter 2's exam? What was chapter 2 all about? The OSI model. And we broke down every layer in the OSI model. And make sure you guys know them from top to bottom, from bottom to top. Know the 7 layers: application, presentation, session, transport, network, data link, physical. Understand its sister model, the TCP/IP model. And when I wrote those down there, I wrote right next to each of those their role. I said the application layer acts as an interface to the network. Went down the transport layer and I said, what's that used for? Identifying communications between applications and services. For segmentating and for multiplexing, correct? We went down to layer 3, I said it's for end-to-end delivery. Is that not what this answer is saying? Used to ensure that data pieces can be directed to the correct receiving end device. On Monday of next week, you guys will learn how that is accomplished. But nevertheless, it is part of the communication process. What is a primary function of the trailer information added by the data link layer encapsulation? This right here. Why do we add a trailer? That's the only time that we add a trailer. Ryan, what's this cable made out of? Well, it uses electricity. There's your hint. Copper. Alright. Anytime we put electricity through a copper wire, what do we generate?
Current.
Well, that's what we call it, but what do we generate on top of that? It's copper wire, it's electricity. You're going to generate an electromagnetic field. Right? Those electromagnetic fields are very susceptible to interference. Like radio waves, like other EMFs. And so the fact is that when data is transmitting across this wire, I don't know if it's running next to an EMF or an RF, a source of high EMFs or RFs. So it could corrupt the data, correct? So the idea of the frame is to detect, the trailer, is to detect if there's any errors during transmission. Because if the data isn't correct, what's the point of passing it up the stack? Because the number could be wrong, and you could be answering the wrong question. Does that make sense? So it's error detection. Which one ensures ordered arrival of data? Which layer? Transport layer, right? Uses sequence numbers. Which one provides correct delivery to the destination? Network layer. Which one identifies devices in the local network? Which one uses local addresses? Right there, folks. Layer 2, layer 1, the frame. Data link layer. Which one assists intermediate devices with processing path and selections? That's the router. That's going to be layer 3. Remember I said the router will de-encapsulate, get to layer 3, look at the IP destination address, find the network address, and select the path. You'll see that definitely in Chapter 5 next week. Which two layers of the OSI model have the same function as TCP/IP model's network access layer? You gotta choose two. What are the 4 layers of TCP/IP model? Application, which is linked to what? 3 layers of the OSI, right? The application layer of the TCP/IP model links to the application layer of the OSI, plus the presentation, plus the session. What's the second layer of the TCP/IP model? Transport. What's the third layer of the TCP/IP model called? What's where things get? It's not called the network. That's what it's called over in layer. That's what's called over the OSI model. What about in TCP/IP? Internetwork. So that means the network access layer is layer 4, which consists of the 2 bottom layers of the OSI model, which are physical and data link. If you guys study those 2 models, you have 40% of this tomorrow's exam. OSI and TCP/IP. What I mean by studying it, I want to know the order. I want to know the protocols associated with those layers. I want to know the PDUs that they produce and what fields are in those PDUs. Knowing those, 40% of the exam. What is a PDU? So what is a protocol data unit? First choice, corruption of a frame during transmission. Does that make sense? Second choice, data reassemble at the destination. When reassembling data, we're doing segments, correct? Retransmit packets due to lost communications. Seems like the first one and the third one are very similar. You can only pick one. A layer-specific encapsulation.
That's what it
Do you
is.
guys see why I told you on your exam you'll be only allowed to see one question at a time? You will answer it and you will move on. You won't be able to go back. You can go back in this exam. This question was asked previously. It was just flipped. We asked what was the role of network protocols. Wasn't that one of the options? PDU, protocol data unit. There's a big association between protocols, encapsulations, and PDUs. Protocols tell us how to encapsulate the data, which creates a PDU. Layer 7. Which characteristics correctly refer to end device in a network? Same question, just asked differently, right? First time we asked this, we asked about intermediary device. Now we're asking about end devices, which gives me what?
Originating the other field.
Yep. Number 8. Now, one thing we've learned about Cisco is that they tend to get really wordy, and they give you too much information. I could really care less about the first sentence of this question. Refer to the exhibit. Cell phone A at IP address 10.0.0.34 has established an IP session with IP phone 1 and IP address blah blah blah. Upon the graphic, which device best describes the function of a wireless device, cell phone A? They're just saying A is calling this phone, hence it's got to be what? An end device because it's creating a message, right? Yeah, it's just, you didn't even know about IP addresses when you came to check your TO. Today you should know this. What does network A and C represent? Local area networks. So then what does B represent? Hey, look right over there, folks. It's written on that board. A WAN, right? Wide area network. Which 3 statements best describe a local area network? So when you're looking at those diagrams, how can we best describe them?
Single geographical area.
Being administered by a single organization, just like this classroom is considered a local area network because I administrate it. The connection between segments in the LAN are usually least connections.
No.
The security and access control of the network are controlled by a service provider. You know, we can implement that. And LAN provides network services and access to applications for users within a common organization. In fact, how do I tell you how we're going to divide our networks into smaller networks? By purpose. Isn't that what that's basically saying? What gives a computer a purpose? Software. You have to read the question to see what they're getting at. What is this process called when they're taking 2 streams from separate communication processes and interleaving them together? Multiplexing. I might ask, what is the process called when you break the data stream up into pieces so they can be multiplexed? What is that called? You take data and you broke it up in smaller pieces. Segmentation. What is the primary purpose of layer 4 port assignments? We're beating this to death. Does it identify end devices? No. IP addresses are used for that. So if it doesn't identify end devices, what are port addresses used for? I told you guys have to know port addresses, like FTP. What's the port address for FTP? 20 and 21. You see a port number, you should be able to identify the application or the service that's running. Hence, when I'm going down through this, I would say this one. To identify the process or the services that are communicating within the end device.
I can't count that.
Forget about that. I cannot identify an end device because that's an IP address. All I can do identify is what's actually being communicated about. What application would be used. Which device is considered an intermediary device?
File server.
Switch.
Oh.
Right? File server is an end device. Don't
Yeah,
think
but
just because all servers are going to be intermediary. Only a few of them are like communication servers. Could I change this switch to another device and still keep the same question? If so, which device could I change it to?
Router.
Router? What else? Hub? What else? Communication service, server, right? Little hint, came from your study guide. Said it many times in this review. I might say, which device is considered an intermediary device, and I replace file server with communication server, and then I replace switch with a TV. A little challenging. Came from your study guide, okay? So most of you guys got that one wrong and bring that up. Same question asked. What do these represent? These are end devices, right? What are these? Do I have to read the question? What is this picture representing? Local area network. What if I hooked up a router off of this switch? Would it still represent a local area network?
Yeah.
Which layer encapsulates the segments of the packets? Segments into packets. Be careful. It doesn't say which one does it put into segments, but segments into packets. And we're looking at the network layer. Know that OSI model, can't say it enough. Which can be identified by examining the network layer header. So we're on question 17. I said this earlier in another question, but it was about port addresses. Now I'm saying, what can we do to identify when we look at a network header? End devices. Identify the device on the local medium to identify host devices. So they're going to be identified destination host addresses, choice 2. Why can't I say on local medium? What address is that? MAC addresses. Okay. Media, MAC, MM. What does E, F, H, I, and J represent? During the encapsulation process, what occurs at the data link layer? I've been repeating myself over and over throughout this exam. What do we have at the data link, folks? What does the frame give us? We saw that on the whiteboard over there. Option 3, the physical address is added on this layer. Question 20, what is the purpose of TCP/IP network access layer? That was the same question up here, but just asked using the TCP model instead of the OSI model. Network media control. Question 21. Big exam question, I'm not even going to go over it. You guys better know the order. Starting layer 7 down to layer 1. Let's go to chapter 3. I'll quickly go through that. What application layer protocol is commonly used for supporting file transfer between clients and servers?
FTP.
FTP. What two forms of application layer service exist? Software exist. We called it application and what else? Services or daemons or processes, right? One runs on the client, one runs on the server. A network administrator is designing a network for a new branch office for 25 users. What are the advantages of using the client-server model? Centralized administration, correct? If I have a server, it's in the center, everybody's connecting to it. Does it require special software?
No.
Possibly because we're running services. And you might want to have a server operating system. So I would put that at the back burner and go on the third choice. Is security easier to enforce when you can have all your users logged into one location?
It's easier to enforce with any sort of protocol.
Well, when it comes down to putting it on a central server, I can remove that file from one area and shut it all down. Just ask Napster back in the 90s. Right? They had a client-server model, and they shut them down overnight. Now I ask what they did next. They went to peer-to-peer networks. How hard is that to shut down? So security, yes, is easier to enforce. What about low cost of implementation? If you're going to set up something to be dedicated to serving people, it's going to require more hardware, correct? so cost goes up. What about a single point of failure? Yeah, that's characteristics, but guess what? They're asking for advantages. All I have to do is pick two according to the question. So I'm going to pick centralized and easy to enforce security. This could be possible, but this is a better choice. Right? That's the way to take a Cisco assessment. What is the purpose of the resource record in DNS? What does DNS do? As you guys are finding, this class doesn't easily come to people. You can't fall asleep on a textbook and get all the answers and know it. It does require you to be actively involved. Reading the book, watching the videos, interacting with the labs. We made one of these in our labs, correct? You had to go to the server. You had to click on config. Over on the left side, you had to click on DNS. Over on the right side, after you clicked on DNS, you had to go to where it said record. You had to add eagle-server.example.com. Then you had to put an IP address next to that. Then you click add, save, and then closed out. That thing you just got done making was called a resource record. Hence, what a resource record does is it's used to resolve a name. Used by the server to resolve the name into an IP address. Folks, those labs aren't just there because I'm bored and feel you guys need to do something. It's taking that theory and actually implementing it. I probably will ask a question like that. What is the automated service that matches resource names with the required IP address called? Just got the same up there. DNS, right? What if I change that question? I said, what is the automated service that gives out IP addresses to end devices called? DHCP. And what port addresses are used by DHCP? There's two of them. 67 and 68. And what type of port addresses are they? UDP or TCP?
TCP, I hope.
Nope, UDP. It's not about establishing a long-term relationship. It's a transaction base. I just need you for this particular service. I'm going to use you or throw your way. Okay? When you are dealing with client servers, like your Facebook, you guys are logged in for long periods of time, correct? Now you're talking about developing a relationship. Now you're talking about using TCP. Now the data becomes more sensitive. In fact, when you're in a long-term relationship, what happens? They become a little bit more sensitive. Correct? It's just, I need an IP address. Once I get it, I'm done with you. I'm used to being thrown away. I'm not going to take it personally. I'm not going to be so sensitive. But I care about the time. Because the longer it takes for me to get an IP address, the longer it is I can communicate with somebody else. Right? So, DHCP. What three protocols operate at the application layer? Talked about that one, right? Talked about SMTP, and we talked about POP. What about ARP and ICMP? In fact, what does ICMP house? What command does that house? The ping. And it's a command, not an application. That's why it's not at the layer 7. The other thing that makes it nice is that layer 3, I don't have to worry about troubleshooting port addresses as well as applications. If it works, I know my connections are established. In fact, that is a question. It's on your review. What is the tool used to quickly assess that the communication between a network, an end device and another end device is successful? The ping command, right? All right, let's go on. What three properties of peer-to-peer applications? So what are the three properties, folks? What's the difference between a peer-to-peer application and a peer-to-peer network?
They act as both a client and a server with the same connection.
Very good. This is a peer-to-peer network. That means if I'm making a request, I become a client, and the other person becomes a server. And in that communication process, there's no role switching. In a peer-to-peer application, I can work over any kind of network. That includes the client-server model. And I can act as both, sharing this file with this person and receiving another file from another person. So therefore, I'm acting as a client and a server. The other property is I can have a hybrid mode, like a BitTorrent, where I can leave all my index files, all the pointers, to a central location anybody can access, download. We call those seeds, right? And then we can start finding out anybody that can feed us the data. So, first one, second one, third one, sorry, first one, third one, fourth one. The rest of it's all the client-server mode. In fact, we talked about earlier about the Napster and LimeWire.
WinMX,
There we go.
LimeWire.
You know what, this might help you guys. Let me just stretch this out. Sorry, a little too late for doing this. There we go. Sorry, people out in TV land. We live and we learn. What application layer protocol correctly match a corresponding function? So we have to pick two of these. Does DNS assign IP addresses?
No.
Another result.
HTTP.
Does HTTP
Yes.
deliver web services? Yes.
POP.
Does POP deliver email from client to the server? POP, from client to the server. No, it's the other way around, from server to the client. POP's for downloading emails using the MDA. What about SMTP? Does that support file sharing? What is
No.
SMTP?
Simple Mail Transfer Protocol.
What they're trying to trick you on is SMB, which is Microsoft's version of file sharing. So Telnet, does that provide virtual connections for node
Yep.
accesses? Yep. You got it. Which email components are used to forward email between servers?
POP, SMTP.
To deliver email
Oh.
between servers.
IMAP.
What's that?
IMAP.
That's actually used to mix webmail with traditional mail, and that can go in both directions.
MDA and
MTA is the mail transfer agent, which uses SMTP to deliver it. So these are the two. MTA and SMTP. In fact, the next question I believe will ask you about those other components. You want to know the email process. No, next question was about what's the disadvantage that Telnet has over SSH, and that is security. Telnet does not support security. But here it is. Write this down, know this process, because you might have this on your question. Oh, by the way, all the exams get from the test bank, so I make multiple questions for each opportunity of a question. So you might get this question, and then somebody else might get a DNS or DHCP question. Remember I asked you what are the 4 steps for DHCP? It was the discovery, the request. Remember those 4? Alright, so here we've got to look at the 4 steps for email. The client uses an MUA called the Mail User Agent, which transfers it using SMTP to an email server. The email server checks to see if the recipient is in its list. If it's not, it'll use an MTA to deliver it to another email server. Alright? The MTA will always use SMTP. It gets to that email server, and that email server looks for its recipients, and if the recipient is on its list, the MTA will deliver to the MDA, the mail delivery agent. Alright, the mail delivery agent will use POP and send it to the MUA, the client, when they make the request. You good about that? Get to know those steps. There's a video on that. Watch it over. Which 2 protocols are used to transfer web resources?
HTTP and HTTPS.
They're so popular I probably won't even ask that question. Now let's skip that one. Which layer of the OSI model supplies services that allow users to interface with the network? Application layer, right? You use programs to interface with the network. If this is all you can see, and you look at the destination port, what service are you accessing?
Web.
Web, port 80. Which 2 characteristics of peer-to-peer network? We've talked about that. Decentralization of resources, and you can share files with that dedicated server. What application layer protocol describes services used by Microsoft for file sharing?
SMB.
SMB. Which 2 characteristics of clients, or sorry, what are the 2 characteristics of clients in the data network? This was like in the last chapter, right? Initiate data exchange, and what else? They upload data to servers. What are the role of the OSI application layer? Provides encryptions,
No.
conversions, no. Provides the interface between applications and the other end
Yes.
network. There we go, same thing again. What does the application layer on the server usually process multiple? How does the application layer on the server usually process multiple client requests? Uses lower layers, right? As report addresses come in. So I'm looking at this, it's gonna say, uses support from lower layer functions to distinguish between connections to the services. Tomorrow I won't talk, you guys will come in, when 9:40 hits the bell, the exam will be open. You'll have 55 minutes to complete the exam. Manage your time wisely, you answer one question, you move on, there's no going back. Good luck,
It's gonna be
I'll
on
see you
this
guys
thing?
tomorrow.